Welcome everybody. Thank you very much for making it out to the first session. I want to talk to you guys today about virtual and augmented reality. In the beginning of human communication, we had town criers. We had people standing in the middle of a town reading out the decrees of the town. Then we had the radio, and the radio changed human communication forever. And from the radio we expanded to visuals, and we showed up with the television, and that expanded across humanity. And now we've got the internet, which blew up, and of course there was people that said, oh, the internet will never take off. Well, they were a little bit wrong on that one. And now, we've got mobile. Mobile is a huge thing. We have a supercomputer in every pocket now, and the future of that is in virtual and augmented reality. And the reason that's important is because this is not just a video game. This is a new way to communicate as humans, and it's a new way for us to get our messages across, and it's the first time in human history where we can actually immerse people completely in a scene that they would never be in before. So it's one thing to show people 2D data on a 2D screen, on an IMAX-sized screen. It's wonderful. But to be able to put them in there and give them agency of the place that they're in, that changes everything, and that's what virtual and augmented reality are doing right now. Technology is sweeping across our communications, and we've seen a huge uptake in the speed in which technology is adopted. So, radios took 30 years to get on board, television a little bit less, and then the internet was a little quicker, about 10 years. And mobile phones took about 5 to 8 years to kind of blow up, mobile phones in terms of smartphones. And if you think about the technology that we carry in our pockets, this is accelerating at a pace we've never seen in human history. And by having virtual and augmented reality, we're actually going to see an adoption curve that is really, really steep. And what that means is more and more people are going to be using this technology faster and faster. And so I'll give you a little bit of history about virtual reality. The first kind of stereoscopic 3D was a stereoscopic microscope where we could look at microscopic particles in stereoscopic, and we could see the depth in there. And then from there, we had, how many people know about the ViewMaster? Remember that thing you used to click and it would take you in a three-dimensional image of the zoo or whatever? I had when I was a kid. That was invented in the 60s, in the 30s. And it became a mainstay of kids' toys, and it never really got beyond that. And then in the 60s, we started experimenting with kind of what can we do with visuals in virtual reality, and we started creating headsets that would be the benchmark for future. The problems were that the equipment needed to make this happen was massive. It was room-sized computers, and the one here on the top right is called the Sword of Damocles. And what that was the first stereoscopic VR headset that had video playing or three-dimensional objects. But it was the size of a room. It had to be hoisted from the ceiling, and you could put it on and you couldn't really move. You could just kind of do this. And so it wasn't really useful. And then we had the Virtual Boy, kind of as the first commercialized product, and that was Nintendo's attempt at bringing virtual reality to the masses. Now, if we forward about 20 years, virtual reality died for a bit. It just kind of stopped because the computing power just couldn't keep up with what was required, which was really fast refresh rates, really high-resolution screens, and super powerful computers. So in 2012, a small company called Oculus announced Oculus Rift, which was a headset that you could wear that would give you full virtual reality control. You could look behind you, look up, down, left, right. And they did a Kickstarter and they raised $2 million. 2 years later, after bringing the first unit to market, which was the DK1, they brought it to market. A bunch of developers started getting excited about it, and Facebook purchased the company for, $2 billion plus $1 billion in stock options, so $3 billion acquisition. And that lit a fire for the virtual reality industry. We've seen an explosion since 2014. And we've seen in the last year, HTC, Sony, Intel, Microsoft, Apple's joining the fold. Everybody is getting into virtual reality. All the main tech companies have a division for this now, and it's rumored that Apple has just hired 1,000 people to work in augmented reality. So this industry is growing a massive amount in a very short amount of time. Last year, in 2016, we did about just a little over $1 billion as an industry in virtual reality. And in 2017, they're estimating that number to hit upwards of $3.8 billion in 2017. Some industry stats. They're anticipating about 171 million people will be using virtual reality by 2020. Citi Financial estimated $1.3 trillion industry in virtual commerce, so virtual reality stores where you would buy your products in virtual reality. And the overall estimate for the industry is about 120, depending on which study you read, between 120 and 150 billion by 2020, which is a massive growth. And to put that into perspective, that's a little shy of what the mobile market is right now. We're seeing 142% growth year over year, and I mean, we only have 1 year to compare to, but it's going to be a huge, huge event. And so what's happening now is everybody, all the industries are looking at this and going, how do we get into this? And so I want to talk to you a bit about how do we use this technology. But before I get into specifics of mining, what is the difference between augmented reality, virtual reality? So the way we explain it, virtual reality is taking people and putting them into a world that is not there. So they put on a screen and they're in a completely different world. I put on a headset and I'm in underwater, or I'm in space, or I'm somewhere else, and I'm completely obstructed, both sound and visuals. And so that's virtual reality. On the other end of the spectrum, you have augmented reality, where it's like Pokemon Go, where you hold your phone up and there's a little critter there, and he's kind of dancing around, but it has no relation to the real world. It doesn't recognize that that's a chair, or that's a floor, or that's a wall. So augmented reality is kind of on the other spectrum. It's just being able to drop things into a three-dimensional space, but it doesn't have relational. And then mixed reality, which is something like the Microsoft HoloLens, which I have here. Mixed reality takes the images of the real world that you're in proportion to what's around you. So being able to drop holograms into a space, so being able to put a little robot or something on my desk, or being able to put screens where I need them. I could put a virtual screen up here, and it would stay proportionate to where I walk around. So that's mixed reality. I think really what's going to happen is we're going to have a convergence of all this technology. We're going to have the virtual reality glasses kind of get really, really super, super high tech. We're going to get these things micro-sized. So, instead of wearing a giant helmet on your head and looking, like a robot, you're going to have a pair of glasses that does this. And ultimately, where this is going is going to be a contact lens, and I'll show you that in a second. So the levels of virtual reality, we've got kind of the introductory virtual reality, and you've got Google Cardboard. There's also plastic Google Cardboard, so it's a plastic version of this. If you guys go over, I'll tell you guys about a booth here that's giving away one of the plastic versions of it. Google Cardboard is really, everybody laughed at it when it first came out. They said, oh, this is just Google Cardboard. What is this? A piece of cardboard with two lenses in it? But when the New York Times put 1 million of these into their newspapers, and they told a story with it and gave an empathy piece about how these refugees in Syria were going through this refugee camp, and put people in the refugee camp. It gave an empathy. And by spreading the love of virtual reality in a very low-cost way, it's actually kind of super accelerated what we're doing. And so that takes me to high-end mobile. So these are the ones you stick your phone in. They're specific phones. So the one on the right is the Gear VR. It uses a Samsung Galaxy phone. The one on the left is a Daydream. And the Samsung Gear VR is about 3 million units so far. And if you look at the Google Cardboard, it's about 10 million units. So it's still not a huge market yet. Mass consumer VR, this is kind of what everybody's going to have in their house. PlayStation made it work, and Xbox is going to come out with theirs as well. And then the high-end ones. This is the ones that you would use for training, industrial training, safety, stuff like that. The one on the left is the Oculus Rift. They've sold about 500,000 units. The one on the right is the HTC Vive. And the one in the middle is actually double the resolution of the two, and it's being used in the IMAX VR cinemas. Augmented reality, we talked about the Microsoft HoloLens. And the one on the right there is the DAQRI helmet, and that's more for construction. So it's a construction helmet with a HUD, or a heads-up display, that gives you information around you. And the reason why these are important is because you need to be able to see the real world. The other ones block out the real world, and by creating something where you can put heads-up displays and holograms around people, you can now bring tools to the field workers that are maybe underground and they need real-time data, but their hands are busy with screwdrivers or whatever it is they're using. It's really important to give people a computer that they can wear so they can get the data when they need it without having to dig in for a cell phone or a tablet. Ultimately, this is going to contact lenses, because in 20 years from now, we're going to laugh at the fact we put a big thing on our head, or we even carried around a phone. They're already working on these glasses now. This is actually for, it's a contact lens for testing insulin. And so the uses for VR and AR in the mining industry, we've kind of broken it down into 3 categories. We've got industrial safety and training. So how do we put people into an experience, or how do we put people into a training scenario where it's really, really expensive to bring them to train? And then the second part is investor and executive virtual tours. How do we fly investors to a site without flying them around the world? How do we bring people inside the mine and show them what's possible inside a mine, or flying over a mine site? So tours are really important. And then the last thing is engineering data and data visualization. I know there's a lot of people here that are really interested on how do we see this 2D data that we're looking at in 3 dimensions and kind of walk around it. And so I think that those are the 3 pillars of how virtual and augmented reality can be used for the mining industry. So first thing is industrial safety and training. We've been doing some demos for the last couple of days of some training that we created for a train simulator where you're on site and you actually have to fix a junction box. And the junction box is on next to a train, so you have to get down there on your hands and knees and fix it. And by doing that, you get this ridiculously visceral experience of the fact that you're standing there and the train goes by and you take a step back because it's right there in front of you. And by putting people in training scenarios, you really, really hyper accelerate their learning. And with training, you've got reduced costs and increased scalability of training. So for example, you look at some of these training scenarios here where you've built a cave for people, and this is wonderful training. It gives them heads-up displays. It shows them what's possible around. We've even got these caves, but this is not scalable. You can't really have one of these in every office around the world. But what you can do is have this, and this is a simple VR training simulator that scales. This particular one is some friends of ours at ITI, and we're actually getting the licensing rights for this. It is a crane simulation, and you're driving a crane in virtual reality. Now, it may not seem like a lot, but when you figure a crane is millions of dollars, and training somebody on that is insanely dangerous, and a lot of what we do in mining is dangerous. So how do we train people safely before they go underground or before they're on a mine site driving a multi-million-dollar vehicle? And so that's what they're seeing in the crane training. And a little anecdote, a friend of ours who works for a VR publication, they ran him through the simulator for 60 minutes. They put him through the simulator and then put him on a real crane. He'd never touched a crane before, and within an hour of training, he got on and was able to maneuver a crane, a real crane. And that's not something that we've been able to do before. Giving people this amazing training tool. Putting people on the field with augmented reality helmets. Again, that's a DAQRI helmet, being able to bring the training to them. So having people in the field that have these helmets that are working, and they're like, damn, I don't know how to do this. They can just call up a central location and say, hey, I'm not sure how to do this. The person on the other end can see what you're doing, and they can say, okay, here's what I want you to do, and they circle it, and you see what they're drawing in front of you. So giving you a heads-up display of instructions, and having super senior people, it's really expensive to fly them around to train all these people, but if you could have them in a central location and help that, it's really important. Investor and executive tours. So one of the things that people are using this for is legal cases. So how do you use virtual reality to show legal cases and show what you want to show? And the other thing is being able to mitigate environmental concerns, being able to show people this is a mine site and this is how we're going to deal with it, and we're going to reclaim it as well. And that's what it looks like in virtual reality. So you look at one of these points of interest, and there's environmental points of interest, there's mechanical points of interest, and they've also got some humanitarian points of interest that they've done. And I thought that was really a great tie-in to the corporate social responsibility of the company and being able to tell that story. This is another one that these guys are here. This is a company called Look and BGC Engineering. And what they've created in the HoloLens is really quite amazing. They've created a 3-dimensional viewing system in holograms. So you can put this headset on, look at a table as a group, and see a 3-dimensional aspect of the mine. You can also overlay data in real time, and you can see what it's like to look at the mine. You can move the mine around and see it in 3 dimensions. It's a really, really impactful way of presenting data to both engineers and investors. What they're showing here is a mine site and how they're going to reclaim it. So there's the mining, and there's all the information, and then what they're doing with that is they're actually be able to show somebody all around you what the mine site's going to look like once it's been reclaimed. So here's the site empty, and here's a site where it's all been reclaimed and there's forests. We worked with Atlas Copco last year, and we wanted to bring virtual reality to their booth last year, and I actually was just down there today. I got this invite in my email, and I was like, oh great, they're using VR. So I went downstairs, and they've got a VR simulator where you can stand in front of one of their drills and walk around it and get a full sense of how big is this drill. You can utilize it, you can figure out how it works, and it gives you an understanding without having to bring a giant drill to PDAC, which is very costly. They brought a digital version where you can put it on and you can walk around it, you can interact with it, and now you've got almost like a training sales tool as well. So this one was really good. Make sure you go check it out at Atlas Copco. And the last kind of fundamental of virtual reality and augmented reality is data visualization. This is kind of the biggest one. And I think, for this industry, data visualization is most important. I went through and I spent a lot of time in the last day or so looking at all the different investor booths, and everybody's using wonderful graphics of magnometers and here's all the data of where we've drilled. But if you're bringing bankers through to look at a 2D wall with some red lines on it, maybe the message is not getting through what you want to portray, and maybe you want to show them this is the mine site we're flying over and have the data come out at them and really create data sets that are rich and visually powerful. Because right now, we can work on 2D planes for data, but working collaboratively with holograms and with virtual reality, you can actually stand inside the data. And that's something that until you've tried it, until you've stood in a mine site, and then the data comes out of the ground and shows you what you're seeing in data, it's really, really incredible. And the other thing that people are using this for is to give the engineers a data visualization of what's supposed to be here versus what is actually there. So standing in a site and going, oh, well, there's a building supposed to be there, but it's over there by 10 degrees. Well, maybe we should flag that. And it reduces the amount of rework. So there's a company we're working with right now, and they've built an augmented reality app where you hold a tablet up in a construction zone, and it shows you all the conduits, all the HVAC, all the electrical, and you can hold it up in an empty room and see where they're supposed to be. And sometimes they're off by a bit. You can circle it, and it updates all of the files real time. So that's really important because rework is a huge, huge problem, and it's a huge money waster. So the other thing is, viewing complex site data. This is kind of what we have now for data in mining. It's lovely, but this is really what we want in data. We want to be able to see this in 3 dimensions, and this is where we're kind of going with virtual and augmented reality. We're not quite there yet, but seeing data in ways that we've never seen, seeing ore bodies come out of the ground, that's really amazing. Being able to flip, our drill sites are going down, being able to flip that upside down and say, here's the drill sites and here's where we think the ore bodies are. It's a really incredible way of showing the data. And that is going to make everybody a lot more of this. At this point, I'd love to take any questions. You can subscribe to our newsletter at metaverse.com/subscribe. So if you want to do that, I'm happy to answer any questions now, and yeah, we'll go from there. Everything that we build, we try to build it on 3 different levels. So we try to build it so that you can be viewed on a 2D screen as well, because it's great to build everything for virtual reality, but it's still in the infancy right now. So we build it for virtual reality ultimately, but you can still look at it at your phone. It's really important to be able to still use a 2D device, whether it's a desktop or a phone. The costs vary dramatically. If you want, full LiDAR scanning of a mine site, so you have really, really rich depth data, so when you stand there, you feel like you're right there. We fly a helicopter or a drone over top, and we get LiDAR scans of the facility. Anywhere between, I would say, 6 weeks and 6 months, depending on what is required. And then throwing data on top, if it's just a 360 tour like they did with the Lucara, we could probably do that in about 6 weeks. And the cost would be maybe $100,000 for something like that. If you wanted like a full, 2-scale replica of the mine that had to be done, it would be a little bit longer and a bit more expensive as well. So you're looking anywhere. Everything starts around $50,000 right now and then goes up from there. Excellent. Thank you.